Greetings and welcome to Talk a Little, Learn a Lot, the American Society of Naval Engineers podcast. I am your host, Stephen Phillips. In this podcast, we talk a little and learn a lot about naval engineering while inspiring the next generation of STEM professionals. Today, I'm joined by Vice Admiral David Lewis, ASNE's president, to discuss his recent article posted on LinkedIn entitled High Volume Submarine Production in World War II. This follows his previous article, and indeed our previous episode of this podcast, where we discussed the industrial integration of design and production in the World War II U.S. Emergency Destroyer Escort Shipbuilding Program. So I recommend listening to that episode as well. Vice Admiral Lewis served as a surface warfare officer. His assignments included USS Spruance, USS Biddle, and USS Ticonderoga. Ashore, he served as Assistant Chief of Staff for Maintenance and Engineering, Commander, Naval Surface Forces, the Naval Secretariat Staff, Naval Sea Systems Command Staff, and Aegis Shipbuilding Program Manager. Upon selection to flag rank in 2009, Lewis served as Vice Commander, Naval Sea Systems Command, and then served 4 years as Program Executive Officer Ships, where he directed the delivery of 18 ships and procurement of another 51 ships. From 2014 to 2017, he served as Commander, Space and Naval Warfare Systems Command, where he led a global workforce of 10,300 civilian and military personnel who designed, developed, and deployed advanced communication and information capabilities. In May 2017, he assumed command as the director of the Defense Contract Management Agency in Fort Lee, Virginia. Admiral Lewis now serves as Senior Vice President of the Maritime Business at Leidos, a Fortune 500 company that provides innovative solutions for defense, intelligence, civil, and health areas. Vice Admiral Lewis, Dave, thank you again for joining me on the podcast. I look forward to this discussion.
Well, thanks for the invitation. I really enjoy this. This is a great forum, and I really thank you for taking this on for the society. I think it really showcases the depth and breadth of what we do at ASNE across all of our disciplines. So thank you for that.
Well, you're so welcome, sir. I really enjoy the whole process for sure. As I said in the opening, this is a second in a series on shipbuilding, in this case, submarine building, during the Second World War. So please share why we should learn about this high volume submarine production during the Second World War.
So, as with a lot of things during the Second World War, Freedom Ford's book talks about it, does a good job. The pre-war military industry was sort of small, sort of bespoke. The Navy had started a major shipbuilding program in the late 30s, so the Navy had a bit of a head start over the other services. But submarines at the time were the most advanced, well, still are the most advanced ships in the naval inventory. There were 2 building yards, Electric Boat in Portsmouth, and I think a little bit of Mare Island. I didn't check on that, but they were building about 6 boats a year, pretty low rate production, craftsmanship based, good designs. I mean, the fleet boat, the Gato class, turned out to be an exceptionally wonderful warfighting platform. It didn't do the mission it was designed to do, but it did the mission it needed to do very, very well, actually. So there wasn't a lot of design required. There was a demand for more than 6 submarines a year. There's a book, 32 and 44, highly recommend it, talk about Portsmouth Naval Shipyard in particular and how they expanded their production to build 32 boats by 1944. It's quite a good book. I recommend it. But the industry as a whole, that was, just have an EB and Portsmouth building submarines, even if they met what they think they could do, wasn't going to be enough. And so somehow this exquisite, good design didn't need to redesign anything. There was no invention needed. How to build more of them? Just turn a crank. And there were no industry. There were no other shipbuilders who could do this work in the U.S. And I think the Navy felt there weren't any industries that could do the work, and yet the Navy was able to find one other shipyard. They tried for a second one, didn't quite work out, and not a shipbuilder, never been a shipbuilder, and they were able to work out with that shipyard. And let me check my numbers here. I think they built 40 or so submarines, which made the difference. Um, and let me look it up here. That was Manitowoc. They built 28 submarines, and the other yard, Cramp, they built 12, although they were slow, and the Mare Island built 17. So they got about 40 ships additional out of this effort beyond the two principal yards. And the reason I kind of keyed on it after looking at it was that, as I said, the issue wasn't a design issue, it wasn't a supply base issue. It was a organizational learning and leadership issue. And the two commercial yards I um, dealt with their demand signal in very different ways, one very successful and one unsuccessful. And that pointed out some of the theories behind organizational learning and how organizations function and how leadership impacts that. So I thought it was a good case study in that topic, not so much on the industrial side, although there was some brilliant industrial management going on. We had talked about destroyer escorts earlier. This is very different than that. That involved innovation and design, and there wasn't really a design to start with. So this one, there's a fixed design, there are fixed procedures, successful design, good design. Didn't need to mess with that. Just needed to get more capacity into the system.
In the article, you outline the strategic pressures, and then, as you were just alluding to this, the industrial demands, and that there wasn't enough shipyards to do this. Um, can you walk us through how the demands evolved, and then what the key bottlenecks were as they stood up these other shipyards?
So the demand was the war in the Pacific. This was somewhat self-inflicted, I think, on the Navy, but there's a couple of good books on it that are worth reading. But um, the official policy of the United States Navy, United States government, and the British government, I didn't talk about this in the article, but was that merchant warfare, anti-merchant warfare, guerre de course was illegal and immoral. And those two the U.S. and Britain had fought hard to get that into the naval treaties of the 1920s and 1930s and failed for a variety of reasons. So until December 6, 1941, it was official naval policy that we will not sink merchantmen in combat. The purpose of the submarine force was to sink battleships and warships. After Pearl Harbor at midnight that same day, the Navy changed its policy and said, okay, they declared we declared unrestricted merchant warfare against Japanese. And the submarine fleet was completely unprepared for that. Operationally, training, weapons, the whole nine yards. And there's a whole other story about that. So when you build a fleet that's designed specifically to sail with the battle fleet to engage in a Mahanian battle in the mid-Pacific, and be an advance guard to sink a battleship or two in preparation for the big battle, you size the force for that. When suddenly you want to operate across the broad Pacific Ocean from Australia to Japan and all points in between, your little fleet doesn't cut it. And Japan was very vulnerable to that kind of warfare. They didn't know it, but the U.S. figured that out pretty quickly. And so while the submarine force worked out their tactical and operational issues, which were substantial, and they had some significant weapons issues, which were substantial. So while they were doing all that, they also needed a much larger submarine force. And so the demand signal went to industry, make more submarines. And the industry kind of said, no, can't do that. And there was, I'm sure, a pretty robust discussion. 42 or 32 and 44 talks about it. And the end result of that was to reach out to industry to see if they could bring in some commercial shipyards and Manitowoc and Cramp. Manitowoc is on the Great Lakes, and Cramp is down in Philadelphia. Cramp was reactivated. I think it had been a partially shut down yard, and Manitowoc had never built a ship in their life. So the Navy put together a process for teaching those two yards how to build a submarine. And it was a build to print. Again, no industrial innovation required or desired. Just build what I tell you to build. And the article goes through the process for that and how it turned out.
Yeah, and so could you compare and contrast those two shipyards in terms of like organization, their culture, their
Sure.
engineering practice, workforce development, et cetera? Because that to me that was a big part of the article was comparing the two.
Yeah. So there's a sociologist, Chris Argyris, I can never pronounce his name, Argyris, and he spent a lot of time dealing with companies and how they dealt with change and learning and organizational principles. And he came up with Model One and Model Two, very, very sexy names. Uh, and essentially, Model One are defensive organizations that they are there to defend themselves, and they behave in an information hiding way, very hierarchical, very command directed, not particularly effective. And then Model Two are adaptive learning organizations that are open, interested in facts over opinions, testing results. And so Model One is organizationally focused, protecting the organization. Model Two is mission focused, achieving the mission at hand. And what the reason I wrote this was Manitowoc was a Model Two organization. They wanted to build submarines, and they were willing to do whatever it took to build submarines. They were very receptive to Electric Boat and Portsmouth engineers coming in and telling them what it took to build a submarine, and they were very open and interactive with them about how to do that. Cramp was a Model One, turned out to be a Model One organization. They had a process, they had a way to do things, and they didn't want to change it to suit those submarine guys, and created a very difficult working relationship. Mare Island was also involved as the West Coast building yard. I didn't really dwell on that too much. I focused on the commercial industrial side. Um, and the other thing that Aguirre talked about was single loop and double loop learning. And you keyed on that, I think, when we talked earlier. And so I guess we'll talk about that a little bit later. But
Well, indeed, it's my entree to the next question.
okay, well, I'll just
I've
keep
been reading
going.
about I've been reading about loops recently. I encountered Nikki Case talking about how you tackle loops with loops and that sort of thing. And so you get into this in the article, the concept of loops in the production process. So could you explain for the audience, what is meant by loops and how they're implemented in this
Okay.
submarine construction process?
Okay, so well, like Iris's view is there's single loop learning and double loop learning. Single loop learning is you fix the problem. I'll use a simple example. The pipe broke. Okay, so I fixed the pipe. Single loop learning, done. Double loop learning says, well, why did the pipe break? Oh, it's an aluminum pipe hooked up to a steel valve. Oh, bimetallic corrosion. So maybe instead of just fixing a broken pipe, maybe I should change the material in the pipe. to steel. So now I got steel and steel, and I don't have bimetallic corrosion. It'll never break again. That's a simplified example, but that sort of thing, that's what Manitowoc did is, okay, you want to build this way, but we have these machines and we have these skills. Can we, take a look at the production process and help us figure out how to set up a production process that meets your requirements using the skills and tools that we have on hand today at up there in Wisconsin. So that was they embraced that double loop learning, and the Navy embraced that as well. And so you get this you get this very productive, useful discussion about, well, why is it like that? What are the reasons for that? Is there another way to get the same outcome but do it in a different way, kind of approach? And that's what Model 2 organizations do. Is It's not just about fixing the immediate problem. That certainly has to happen, but it's looking a little bit deeper so you don't keep having the same broken pipe over and over and over and over again. And Cramp didn't do that. So they would build a submarine wrong and then they'd have to fix it. And then they would build the next submarine wrong in the same way, and they would have to fix it again in the same way. And learning didn't happen. And the learning isn't just production learning. That's the one everybody talks about. But the learning was also management learning, engineering learning, leadership learning about this entirely new thing called building submarines. And Manitowoc did it really well. And they were further hampered because they are on the Great Lakes. And if you check, there's not a lot of good connections between the Great Lakes and the ocean. And the Great Lakes freeze every winter, like solid. So how do you get submarines out of the Great Lakes? Well, they came up with a very creative way to they side launched them, which had never been done. And then they barged them down the Mississippi River, and they went and entered fleet service out of New Orleans. So that was a whole other problem in and of itself. But that's where Model 2 organizations embrace the principle of double loop learning. The objective is to meet the mission. So what do I need to do to meet the mission? And if I'm doing something wrong today because it's not meeting the mission, then why am I doing that? How can I do it better? And and that approach actually stayed with the submarine force and enabled what happened later with Navy nuclear power and Polaris, which is what I see in those organizations is Model 2 organizations is why does this happen? Why do we have to do it this way? What's a better way to do it? What's the point is safe operation of nuclear reactors. The point is safe launching of ballistic missiles from underwater. Neither is an easy goal, and what's it going to take to get that? And very open, very receptive organizations, and I think that at least partially came from that experience building submarines at Manitowoc and Cramp and in the industry, and learning that just because you've done it a certain way in Electric Boat or at Portsmouth doesn't mean that's the way it always has to be. And that there is a way of being good engineers, good stewards of the taxpayers' money, building safe submarines that take sailors in harm's way in a very hostile environment, and do it differently than how you've been doing it for, at that point, 40 years. And I think that's a big lesson out of this for me, and frankly, a principal reason why I dug into it, if that helps.
How did each shipyard handle workforce scaling, given that so few of the workers had the skill or the prior experience in submarine building? And I'm interested, did one of the yards adopt a different approach from the other?
Um, Obviously, with the Army recruiting 2 million soldiers and the Navy recruiting 2 million sailors, and the workforce was an issue. I think that was an industrial policy issue. I think the United States, that's another discussion, handled that well, but defense workers were protected, and they did have workforce issues, but Manitowoc had an experienced core workforce. They were an active going concern. And so it was a matter of those people learning new techniques, which they did. Cramp had been reactivated from some, not zero, but some relatively low state. They had some issues hiring, and they're competing with Philadelphia Naval Shipyard. That's Philadelphia at the time was a heavy industrial area, lots of shipyards. So they had some workforce competition issues, and they had a pretty rigid process in place for building ships, and that's where the Model One piece came in. Is they were not generally willing to change, or they were resistant to changing their established processes, and that made the workforce issues harder. And I would say other countries did not handle that as well as the United States did. And that's reflected, I think, in the success of this program, as the United States recognized that an experienced welder was somebody you did not want to put in a uniform and send to the Pacific Front or to D-Day. That person had a war-winning skill right there at home. And I compliment the folks at the time for recognizing that and accommodating.
Yeah, absolutely. So let's drill down a little bit more on the technical or engineering side. How did each of these shipyards compare and contrast? I'm interested. What choices did they make on their engineering technical side that caused the success or failure, or the impact on quality, speed, reliability, etc.?
So my short answer is yes. Manitowoc was mission focused. It's like, what's it going to take to get these ships built, these boats, sorry, built? And they were very receptive to guidance from the shipyard, from Electric Boat, and from the Navy. So I have a section here. I'm digging it out. So there was a high level of organizational diversity and a very high level of compliance with roles in this process. So Electric Boat was the design mentor and the technical integrator. So they owned the design and they owned the integration of the engineering and the technology. Manitowoc willingly adopted the adaptive learner role. So they were the enthusiastic, I really want to do this. I don't know what I'm doing, but I'm willing to listen to you and I'll do what you tell me role. No pushback or minimal pushback. And Cramp didn't was not an adaptive learner. Cramp was, I know how to build ships. You can't tell me what to do. And that tension then really became a problem. And the Navy, through Portsmouth Naval Shipyard principally, was the mediator and the arbiter of issues and concerns in all of this. So the system that was set up, I think it was designed, it ended up being designed to do that, but I'm not sure it started that way, where you had a kind of a mentor-protege relationship between Electric Boat and Manitowoc and Cramp. And Cramp wasn't a particularly good protege, and Manitowoc was. And the difference you can see in the production, Manitowoc had double the production and generally delivered on time, about on time. Cramp was half of theirs and often late. And many of the boats that were finished were too late to fight, or very late in the fight. Into 1945, there frankly weren't many Japanese ships left to sink. So so the Cramp boats came in very late in the process, and they would have been more helpful, a year earlier.
It almost sounds like the challenge was more cultural than anything
Yes.
else as a
Yeah.
result.
Yeah. As I get into this kind of stuff, I find that culture is dominant. It's not the engineering so much as it is the culture in many cases. And that culture, in a stable environment, that culture is fine. When things aren't changing, culture is okay. It's been successful, and it continues to be successful. When it's a time of transition, like we are today, like we were then, That's where culture is challenged, I guess. I'll put it that way. Where everything you know may not be true anymore. And how does a person react to that? And how does an organization react to that? Do you hunker down? Do you become defensive? Are you a Model One organization where I'm right and you're wrong and don't tell me otherwise? Or do you become a Model Two organization? A lot of times that's solved by creating a new organization. Example I've used in the past is Bureau of Aeronautics, created in 1920 when they had this new aviation thing. Do you give it to BU ships? No, they stood up a new organization called BUAir, put an admiral in charge, and said, "Go for it." And they were a Model Two organization. The Army didn't do that with aviation. They did not create a new organization. They just spread it out amongst what they had, and that didn't go well. That's another article.
Yeah. And did the concept of the loops concept or the Model 1 versus the Model 2 concept carry on in shipbuilding after the Second World War?
Yeah,
Like, did it sustain itself?
yeah, that's a weak link. I need to expand on that a little bit, but yes, you had this experience in 1942 to 45, and then nuclear power and Rickover showed up in 49. I had a neighbor and friend that went to Germany right after the war and was much enamored with V-2 rockets being launched off of submarines. So that what became the Polaris program and the nuclear power program sort of originated in the late 40s from different sources and progressed together. And like I said earlier, those organizations were very clearly Model 2 organizations, very adaptive, very open. They were both new organizations, so they didn't carry a lot of baggage, and they did amazing things amazingly quickly. And again, there was a third industrial revolution that started in the middle of that, 1950, and that's nuclear power, space, rockets, computers, all of those things. And those two organizations were quite receptive to all of those and applied them, I think, in a good way. And Electric Boat was the principal builder of nuclear submarines, along with others. And they had that experience from the World War II building program. So, and the Navy had worked with them in that way. So I think that culture of collaboration and cooperation was established during World War II. I think that my evidence for that is thin, other than anecdotal, but clearly what happened in the late 50s and in the 1960s is evocative of what happened under uh, submarine construction in World War II.
I suspect too, we'd look at Aegis and Admiral Meyer as a
Yeah,
Model 2 organization. You know,
exactly.
clearly, I've always thought there was a lot of influence of Rickover in Admiral Meyer in
Yeah.
almost everything they did in a positive way,
Yes,
Yeah.
yeah, I agree, and that's where the new organization thesis comes from, and I see the Navy is standing up a new has stood up or is standing up a new organization for autonomous robot ships, and I think that's a brilliant and inspired move.
Well, sir, I'd like to close out this interview as I did for the previous one. In your role as president of the American Society of Naval Engineers, how do you see the relevance of this historical case study as we, face our new shipbuilding demands, as we try to be ready? We're in the phase zero, as we've talked about, but being ready for future phase one, et cetera. What should our listeners take away from all this, from that perspective?
So, I mean, ASNE was founded to facilitate communication and collaboration between industry, academia, and the maritime industry. In this case, pretty much Navy for submarine stuff. But I mean, that was the problem the Navy faced in the 1880s. It was the second industrial revolution then. All these new technologies were flooding into into the world, and the Navy was way behind the eight ball. I think we ranked somewhere amongst the South American navies in terms of our technical and operational capabilities, and not among the first rank of naval powers. And so several naval organizations were born during that time, created during that time: ASNE, SNAMI, Naval Institute, several others. Navy League came a little bit later. And with that exact mission of informing, enabling, teaching, communicating, and we're successful. The Navy, the U.S. won the Spanish-American War just not even 20 years later, after the new Steel Navy was created during that 1880s decade. Remarkably fast integration of very advanced technologies, for certainly for the time. And then by World War One, the United States Navy was second to one, the Royal Navy, and by the 1930s, second to none. So in a space of 50 years, went from not much to the best in the world. And today we're at the front end of the fourth industrial revolution. All these new technologies coming in, very impactful. How do we incorporate those into the maritime and naval domains? Uh, Struggling with that. It's a challenge. And I think ASNE's role is as relevant today and as important today as it was when we were founded. And the topics are different. Now it's AI, quantum computing, ubiquitous space, those sorts of things. And so it's a different topic space, but it is as important, and our role in that is as important and as critical and as necessary. Without that, we don't have that organizational learning. We don't have that interchange of ideas between industry, government, and the Navy. And the Navy needs to know what's going on. And that's a change for the Navy, because we've been in a very stable, and the Navy's been in a very stable environment for a long time. All these new things are happening, and it's disrupting a system and a process, and you're seeing that happening. And I think we, ASNE membership, can be a leader in that area. Should be a leader. I think we are a leader in many areas, but conferences, symposia, training sessions, this sort of, I really appreciate what you're doing in this, because this is
Thank you.
part of that ASNE mission, is informing and communicating and connecting people up that have different ideas about things. And gee, let's talk about that a little bit. Why did you say that? Why do you think that's true? And well, I've got this problem. Could we fix it this way? Those are the conversations that are important. And those are the conversations, when I go to ASNE Symposium, those are the conversations that are happening in the passageways and over the coffee machine and in the back of the room, as well as in the front of the room. I mean, we have the presenters in the front of the room, and they're doing a great job, but in the back, I'm talking about something else, unfortunately. And I probably should be paying more attention, but that's good. That's important. That's the reason we exist, is to have those conversations. The Bob and Mary and the Bill and Joe and the Mary and Fred conversations are why ASNE exists. And those relationships, when you can call up somebody in industry and ask them, or industry can call somebody in government and ask them or tell them. And that's how we make a better Navy. And ASNE, I think, is front and center in that role. And we need to remember that, and we need to embrace that as a society.
I agree, sir. And one of the things that I can continue to reflect on, and it's something I've heard you say before, I think there's a lot of young people out there right now who don't think of themselves as being in naval engineering, or don't imagine themselves in the shipbuilding industry, but soon will find themselves in this role. And they're young people that are learning computer aided drawing, or they're learning additive manufacturing. They're in some form of digital engineering. And right now they think, I'm a mechanical engineer, I'm an electrical engineer. I don't, and they're going to soon find themselves as naval engineers, marine engineers, because that's where they're going to be as we continue to ramp up shipbuilding in this country.
I
So
agree. I would say they're already naval engineers. They just don't know it.
they just don't know it yet. Yeah, indeed. Indeed.
And it's not. I use the term motors and rotors. It's not motors and rotors. It's everything is software today. So
Yep.
the person writing code for an autonomous ship is a naval engineer,
Yeah.
100%. And what they know and what they're doing matters. And it affects how the ship is designed. It affects how the ship is operated. It affects how the ship is sustained. And so they need to be in the conversation, um, because they're going to write code that's going to make that thing do something. And they need to know whether that's the right thing to do or not. And they need to be aware of that. I remember I'll take a diversion if you don't mind. In one of my prior lives, the Navy was having a lot of trouble with diesel engine reliability. Big main propulsion diesel engines, the big diesels on ships. And in that capacity, I was in the sustainment fleet world at the time, and I arranged to have some Navy engineers go on a ship and actually see the procedures that they were writing being used by sailors, third class petty officers, second class petty officers. And we took them to sea. Most of them had never done that before. And then I sat with them on the mess deck. So I got an engineer with a master's in mechanical engineering on one side of the table, and I got Petty Officer Jones on the other side of the table, who is the roving watch on number two engine room, and and I'm sort of facilitating conversation, and the petty officer is telling the engineer, the petty officer is looking at the PMS card, the planned maintenance system card that he's following as he goes around on his watch, and he's telling him what he's doing, and the engineer is sitting there going, no, 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 I didn't. That's not what I meant. And that communication matters. And the engineer was doing good engineering, but the petty officer had gone through sea school, and he'd been told that when you take readings, this is how you do it, this is the range, and this is what you'll use. And the engineer didn't know that. He did after that. He changed the PMS card. But that's the kind of communication that matters, and that's important.
Absolutely.
And that's the kind of stuff ASNE can facilitate. So it's not just ship design, it's also maintenance and sustainment and operation as much as we can. So that's why we have FMMS, and that's why we have Mega Rust, which are more sustainment focused. And that's why we also have TSS and CSS, because those are tend to be more design focused. But those communications are important, and there often isn't a process for them to occur unless somebody intervenes, like I did as a junior officer, and as we do during symposium. So it's important to have industry, academia, and the Navy together, and I think that's our role as ASNE. So
Yeah,
enough of
absolutely.
me for a minute.
Yeah. All right, then. Thank you, Vice Admiral David Lewis, for taking time to discuss the submarine production during World War II, the second in our series about World War II ship and submarine production. I know, sir, that we will certainly welcome you back again on Talk a Little, Learn a Lot, the podcast of the American Society of Naval Engineers.
Thank you very much.